Okay, so we're talking about trig functions. Let's now look at solving trig equations. So all the different trig identities and results that we've seen will come in handy. So the compound angle formula, sine, cos, cos, sine. If it's a sine, it's a sine. Cos, cos, sine, sine. If it's not the sine, it's not the sine. And tan plus tan or 1 minus tan, tan. Okay, so we started with those. From that we created our double angle formulas. So sine 2 theta became 2 sine theta cos 2 theta, cos squared minus sine squared. But if we wanted it just in terms of cos squared, it becomes 2 cos squared minus 1. That one is handy for integration, certainly, making cos squared the subject. Or we could write it so that sine squared, so 1 minus 2 sine squared in fact it becomes, and then we could rearrange that one to make sine squared the subject. And tan 2 theta, there it is, 2 tan theta on 1 minus tan squared theta. From there, that was the double angle results. The t results, which you could think of as the half angle results. So we let t be tan theta on 2, or half the angle we're dealing with. So tan theta becomes 2t on 1 minus t squared. That's just the double angle result. But then we could draw up a triangle, and I'm not saying you do, you just know these formulas, don't draw up a triangle each time. But if you do forget, then that's how you could do it. Sine theta then becomes 2t on 1 plus t squared, and cos theta becomes 1 minus t squared on 1 plus t squared. Then we had our products to sum formulas. So how do we change a product to a sum? And as I mentioned last week when we looked at an example, if you don't remember, think about where it came from. So if I've ended up with sine cos, it must have come from the sine formula. So 2 sine cos becomes sine a plus b plus sine a minus b. Cos cos must have come from the cosine formula, but if you're left with cos cos, it's the sine sines that have cancelled, so you would add the two coses together. Whereas if you're left with sine sine, it also has come from the cosine function, but now in order for it to cancel, you would subtract. Now, there's two ways I've written that. Formula seen in a lot of books is cos a minus b minus cos a plus b. It might be easier to remember it with minus cos a plus b plus cos a, because then that way they're all a plus b in the first trig and they're all a minus b in the second trig. Then you go back the other way. Sine plus sine, 2 sine half sum cos half diff. Cos plus cos is 2 cos half sum cos half diff. Notice they both end in cos half diff. And they start with the ratio that we're talking about. So the sine plus sine starts with the sine, the cos plus cos starts with the cos. And then we get cos minus cos. That's a bit different. So because that's a bit different, instead of ending with the cos, we end with the sine. And instead of starting with plus 2, we end with minus 2. And instead of starting with the function that we've got, we don't start with the function we've got. That's a bit different. So it becomes minus 2 sine half sum sine half diff. Now, the products to sum formulas are on the reference sheet. The sum to products are not, because that's not actually in the syllabus. However, that doesn't mean we can't use it if we know it. Okay, so there are sum to products. That's why I put the asterisk there. Not actually in the syllabus. Okay, so let's go and solve some trig equations. Basic idea is to get all the angles the same before anything else. So all in terms of theta or all in terms of 2 theta, whatever the angle is. Then match the range to the angle. So if they say theta is going between 0 and 360, but your angle is 2 theta, then you're looking for angles where 2 theta is in between 0 and 720. You'll go around the circle twice. Then try and get all the trig functions the same. So all cosines, sines, tans, whichever. And then you just treat that like it's a pronumeral. Now, if you're in doubt, change everything to sine and cos. It's probably the easiest way to go. Check your answers solve the original question though, not the one you've transformed. Because you're using trig identities, you're changing the question. Now, it will come up with the solutions to the original equation, but it might create other ones as well. So you should be checking that. Start with a very basic one there. Cos 2 theta equals a half. Okay, so, well, 2 theta, they told me theta's between 0 and 360, so I'll make 2 theta go between 0 and 720, go around the circle twice, and I can just do it like a normal trig question. I'm in quadrants 1 and quadrants 4. Whoop, there we are. The acute angle there would be 60 degrees, so 2 theta in this case will either be alpha, that's in the first quadrant, or 360 minus alpha in the fourth quadrant. So there's my possibilities for 2 theta, but notice I have 4 answers because I've gone around the circle twice. Well, we want theta, not 2 theta, so we just divide everything by 2, and there we go. Okay. Now, of course, the other way we could do it is we could use double angle results. So cos 2 theta, I could rewrite 2 cos squared theta minus 1. And rewriting that, cos squared is 3/4, so cos is plus or minus root 3 on 2. So I'm actually in all 4 quadrants now. Oh, look at that, we've got the butterfly. The acute angle is 30 degrees if I'm doing it this way, but it's in all 4 quadrants. So again, we end up with those same 4 answers. How you choose to do it's up to you. 4 sec squared is equal to 3 tan. All right, well, it makes more sense to write everything in terms of tan, doesn't it? Change the sec squared. Sec squared is 1 plus tan squared. We end up with a quadratic equation. But the pronumeral, if you like, is tan x. So this one factorises, that was nice. So tan x is minus 1/4 or equal to 1. So just dealing with them one at a time. Tan's negative in the second and fourth quadrant, of course. The acute angle works out to be 14 degrees 2. So subbing that in, we get 2 possibilities for x. Now tan x equals 1. Well, that's a lot nicer because that's one of our exact values, isn't it? So we know that the acute angle would be 45 degrees. And then a final solution. I like to put them in numerical order because I just think that looks neat. Cos 2 theta, 4 cos squared minus 2 sine squared. Well, which one will I use? Cos 2 theta, I've got 3 choices. I think I'll probably just go with the cos squared minus sine squared, because that way I can play around with this one and end up with tan squared. Okay, so a bit of division, we get tan squared is 3. As I say, so tan theta plus or minus root 3. In all 4 quadrants, the acute angle is 60 degrees, again one of our exact values. And we end up with 4 possibilities. Now here's one from an HSC. Cos 2 theta is sine theta. This time I'll use the 1 minus 2 sine squared theta for the cos 2 theta. Again, we create a quadratic. Does that one factorise? It does. So 2 possibilities, and they're both exact values. That is good. They were nice, that particular HSC, weren't they? So quadrant 1 and 2, we get acute angle of 30 degrees. So there's our 2 possibilities. The other one is a boundary value. So it's just going to be 270 degrees. So 3 possibilities for that equation. Oh, 1992, goodness me. 2 sine squared is sine 2 theta. Well, I guess we change the sine 2 theta. 2 sine theta cos theta. Move everything to one side. Oh no, I don't have to change the cosine because I just factorise the sine, and then I get the possibility that either sine theta is equal to 0 or sine theta is cos theta. Well, sine theta equals 0 is a boundary value, but this brings up a very important point. Whenever 0 is a solution, 360 is a solution, because you're including both ends. It's amazing how often people leave one or the other off the solution. The other one we can turn into tan theta is 1. And there we go, acute angle 45. We end up for this one, 5 possibilities. Product to sum. So sine must have come from, and are we adding or subtracting? So it'll be minus cos the sum, so the sum is 4 theta, and then it'll be plus cos the difference. The difference is 2 theta. When you're dealing with cos, of course, the difference, it doesn't actually matter which way round you go, because cosine's an even function. So whether you said theta minus 3 theta or 3 theta minus theta, doesn't actually matter. Okay, now I'll use a double angle result on the cos 4 theta. So I now have everything in terms of 2 theta, which means we're looking for solutions between 0 and 4 pi. And that factorises nicely. There's our 2 possibilities. Now make sure you do answer in radians. Now the question has said theta is between 0 and 4 pi. So don't write down 90 degrees. No, it's pi on 2 radians is the answer. And divide that by 2. Now let's go do the other one. The other one's in quadrants 1 and 4. Acute angle is pi on 3. 4 possibilities because we're going around twice. Now let's combine that all together. How good are your fractions? Which one goes first? Pi and 4 or pi and 6? Very good. So there they are. Pi and 6, pi and 4, 3 pi and 4, and so on and so on.